Section 1.3, we're looking at using the midpoint and distance formulas. Our essential question, how can you find the midpoint and length of a line segment in a coordinate plane? Our answers would be midpoint formula for midpoint, distance formula for length. So then defining our terms, okay, midpoint is the point that divides the segment into two congruent segments, which is the blank. I underlined the blanks, they're typed out here. All right, but the midpoint is the point that divides the segment into two congruent segments. Segment bisector is a point, ray, line, segment, or plane that intersects the segment at its midpoint. Okay, so bisect means cut it in half. Segment bisector is cutting a segment in half. A midpoint or a segment bisector, both of those bisect the segment, meaning they cut it in half. So our first example, example 1, asks us to find RS. Okay. The dashes here aren't dividing those lines. That's saying that RT and TS is equal. So RT is 21.7, so TS is 21.7. So I can add those together, 21.7 plus 21.7, or I can double 21.7, both of which get me 43.4. Example 2 now takes us to the algebra part. Point C is the midpoint of BD. Identify the segment bisector, then find the length of BC. The segment bisector is just point C. Okay. Cuts it in half. To find the length of BC, I need to find x. So I'm going to do 3x minus 2 equals 2x plus 3. Then I'm going to solve that. So I add 2 to both sides. 3x equals 2x plus 5. Subtract the 2x. X equals 5. And I'm looking for BC, so I plug that in here. So I have 15 minus 2, and my final answer is 13. Do watch in geometry that you're finding what you want. Sometimes it'll ask you for X. Sometimes it'll ask you to continue past that. So do watch that. Example 3. Find the coordinates of the midpoint of the segment with the given endpoints. Right? And it gives me the midpoint formula right here. X1 plus X2 over 2. Y1 plus Y2 over 2. It doesn't actually matter which one you pick as X1 and X2, Y1 and Y2 as long as you're consistent. So if negative 2 is my X1, then 5 needs to be my Y1. And 4 needs to be my X2, 3 needs to be my Y2. If 4 is my X1, then 3 is my Y1, 5 is my Y2, negative 2 is my X2. Okay. So just make sure you're picking from the same thing and you'll be fine. Okay. So to solve this, I just plug it. Negative 2 plus 4 over 2. 5 plus 3 over 2. And how much you show here is based on how much you need to think through this. Negative 2 plus 4 is 2. 2 divided by 2 is 1. Okay, so if you can see that, you can just write 1 there. If not, negative 2 plus 4 gives me 2 over 2. Right? 5 plus 3 gives me 8. So I have 8 over 2. So my final answer here is 1/4. Then turning the page, example 4. Use the given endpoint of A and the midpoint M of AC to find the coordinates of the endpoint. So if you're setting this up from the equation, okay, your x1 plus x2 over 2 is equal to this. So you would have 1 plus x2 over 2 equals 3. You would do the same thing with the y. You would have 6 plus y over 2 equals 4. I can solve that and get my point that is x1, y1. Another way to look at this is by sketching it out. Okay, I have a line. Okay, it doesn't matter what direction your line is going in. This point here is 1, 6. The midpoint is 3, 4. I want this part down here. Because it's the midpoint, the change is going to be consistent. So 1 to 2, my x, I'm adding 2. So my x, I add 2. That gets me 5. Here, 6 to 4, my y, I'm subtracting 2. So I do that again. The fact that they're both 2's is just coincidence. Okay. Subtract 2, 4 minus 2 is 2. So 5, 2 is my answer. If I do the algebra on that, I will get the same thing. But generally, people find this to be an easier way to think through it. And then our final example, example 5, looking at the distance formula. So our distance formula is the square root, right? It's big thing here is our square root. So I'm doing the square root of x2 minus x1 squared plus y2 minus y1 squared. And the key thing here is that you pick them consistently. All right. So if I say this is x1, this is my x4, or x2. So I have negative 4 minus 3 squared plus 3 minus 2 squared. I do not suggest putting this all in your calculator. Odds are you're making a mistake as you plug it in, but you can do that. Watch your order of operations. I do inside the parentheses first. So negative 4 minus 3 is negative 7. 3 minus 2 is 1. Then I'm going to square. Remember, when you square, you always get a positive. So negative 7 squared and 7 squared are both 49. Right? 1 squared is 1. So I have the square root of 50. That will get me approximately 7.07. If you've done simplest radical form, we will do that later in the year. You're welcome to give your answer in that always, which is 5 root 2. For right now, for most of you, if you're not familiar with that, 7.07 is what we would take as the answer. And that is the end of section 1.3.